I'm a senior staff software engineer at Split. I've been at Split only about 6 months now, maybe. Prior to that, I was at Box for quite a while, around 8 years. And I guess, so I'll be talking about service architecture and domain-driven design. And sort of my main impetus for this was that I worked on a larger project at Box to split our monolith into microservices. And I was on the team that really explored a lot of the research behind how we were going to think about where we wanted to draw those service boundaries. So a lot of this is actually directly out of that team project that I worked on. So that's kind of the background of how I learned about all this stuff and the main reason I know some of these things. Yeah, so let's go ahead and get started. First of all, I'm just gonna kind of talk about what I mean by this, and then why we even care, and then sort of dig into how we thought about service architecture, and then specifically talk about domain-driven design and some of the examples on that side, as well as layered architecture and some of the examples on that side. So what do I mean by service architecture, since that's pretty overloaded and can mean many, many different things. So your typical SOA architecture might look something like this from, I guess, the server side. So a request would come in, there's API gateway, a bunch of different services. I'm sure I'm missing a couple things, but in general, this might be a typical SOA architecture. Within this is actually the section I'm going to focus on. So while there's a lot of necessary infrastructure components that are needed by almost any microservices architecture, I'm really going to focus on how to think about dividing up your actual business logic and your actual main application into services and how you might want to think about that. So that's really what I'm focusing on here. So why do we care about service architecture? So a lot of us at Box, for sure, and to a lesser extent at Split right now, we had monoliths where over time they were built up, and more and more connections got built. They got very interconnected, kind of messy, giant, something like this. And we really wanted to avoid just pulling those out into microservices and ending up with essentially a distributed monolith. Right? Like, we don't want to just add latency to the mess that's already there. We wanted to clean things up in the process. So that's one reason to care about how you divide things. The next thing was around code repetition. So as you're building services, you don't want to end up in a situation where you're adding a piece of code to one and then the same thing to another and over again. Because then if you ever want to update this piece of code, it's really, like, in a monolith, that's annoying to update all the places, but in a microservices world, these are different services. They're potentially different code bases. Like, that's even harder to update every single instance. So you really don't want to do that. Another issue is around hyper localized optimizations. So as you're building things, it's tempting to really think about the exact problem at hand and make sure that you really optimize for that. But again, the problem sort of comes in that once something changes a little bit, suddenly things don't fit together well. And then the final piece is around just chaos, right? Like, as you're building your first services, they probably make some sense. You build a couple more, and then, eventually you end up with this. So we wanted to avoid that. So how do we think about this? How do we approach this problem? There were really sort of two ways we thought about it. So if you have microservices, you can divide things really in two ways. So the first one is sort of vertical by like functional areas and thoughts. And for this, we used domain-driven design and created domains and bounded contexts, which I'm going to go into in a minute. And then the other is more vertical. So this is like front end, middle tier, and back end sort of dividing. So and for this, we used a different framework, which I'm calling layered architecture. So I'm also going to go into that a little bit. So first of all, what is domain-driven design? Sometimes called DDD. So domain-driven design is an approach to developing software for complex needs by deeply connecting the implementation to an evolving model of the core business concepts. Domain-driven design actually isn't new. So it's actually been around since 2004. There's two primary books that people in like deep in domain-driven design tend to refer to. We lovingly called them the Blue Book and the Red Book. The Blue Book is actually, Eric Evans's book is actually the original book that coined this phrase. So he's sort of like, this book is actually what kicked off this whole idea and this whole concept. That said, even though this was developed in 2004, I came across a random posting that was like the top 6 domain-driven design books in the past year, which was posted like within a couple months. So I mean, this is still something that's very, very on top of a lot of people's minds and still very relevant to how we design architecture. So the principles of domain-driven design, the first one is focusing on business value over technical strategy. So as engineers, it can be really tempting to go after that shiny new technology and figure out how to make it work with your system. You know, you want to try it out, you want to play with it, but domain-driven design really says focus on getting the most business value you can and try to make like, obviously don't pick bad technical strategies, but like use them as a tool to get that business value, not vice versa. The second one is cross-functional collaboration. So this is obviously working with people like front end and back end, but it also means working with marketing. It means working with customer success. It means working like fully cross-functional across the company to try to solve your problems. The next principle is big picture over point solutions. So kind of what I alluded to before, you don't want to focus on fixing just the little thing at hand, but you also want to think about how might this generalize in the future and how can I make sure that I fix not just this, but anything else that might be related to that. The next piece is basically just software best practices. I've listed a couple here, the first one being separation of concerns. And then the next one I listed was simplicity, but realistically, domain-driven design is not meant to be exclusive of other software best practices. It's meant to be more of a mix-in. So really any other things that you like test-driven development or other processes that you use are meant to be used in conjunction. So still, obviously, software best practices are a good thing. And then the final thing is once you come up with your domain model, your business is changing. So that means your domain model should be changing as well. Nothing stays the same, right? You want to make sure that you keep updating the way you're thinking about your problems at the same time that the business is updating. So this should be be a constant conversation and an evolution over time. It's not a single thing that's static once you create it. So that's sort of the main principles behind domain-driven design. Now there's basically 3 core concepts that are pretty central to how you think about it as well. So the first one, which we think about the most, is domains and subdomains. So a domain is really just a problem space. It can be any problem space. So for example, Split is a domain, right? Like our company, our entire company, all of what we do is a domain. However, like if you think about it, a single engineer is not really going to be able to wrap their head fully around the details of every single thing within our application. At least I know that I never could. I wouldn't even want to try, right? Like I might have a high level picture of everything and I might have like a little bit of more in depth in a few areas, but really it's going to be a smaller subset that I can really dig into and really know well. So you really want to divide this up into smaller areas so that engineers can really, or not just engineers, everybody working on the problem can really wrap their head around, ideally, the entire domain space. And then like, as you get larger, as you build more things, you're probably gonna end up dividing those into smaller and smaller subsets. So typically there's sort of domains and then subdomains live within a domain. So you would have like a larger group thinking about a domain, but then you might have subproblems within that domain. So like a feature or a set of features might be a subdomain. So how do you draw these lines? How do you think about the domain or subdomain? So we sort of said you want it to be roughly the size of what somebody can realistically think about. And then, but then like within that, how do you draw commonalities? So the first thing is bringing together everything that's solving the same problem. So even if you have completely disparate features, if they're trying to solve the same underlying customer problem, they likely belong together in the same space. Because as you're thinking about creative solutions to solving that problem, it might interact with multiple of those features, and it might even replace multiple of those features. So it's useful to have the same people thinking about those things. Another thing is if things are really tightly coupled, then maybe it's not like bacon and eggs. Maybe it's not worth separating them, right? Like if they are truly very tightly coupled together, while I love modularity, there's sometimes a reason that things are coupled and it's sometimes not worth the effort. So those things also might live together in a single subdomain. And the final thing is sort of this idea that as you add something new, you want to be able, so you want it, the domain such that as you add something new, you can keep the full picture in mind too. So this is sort of related to that size that you can keep in your head thing I was talking about. So the thought there is that like, as I'm adding this new feature, I should generally be able to have some idea of all of the things that it's likely going to interact with and how that's going to fit into the larger picture. This also sort of ties back to that principle of domain-driven design of the big picture over point solution. So as I'm fixing something, I need to be able to have the larger picture in mind at the same time. So that's sort of how we think about dividing things up. So now that we have, let's say we've divided things into our domains and subdomains, we further classify them in domain-driven design into 3 types. So the first is core subdomains. Second is supporting subdomains, and the third is generic subdomains. So what are these? Core subdomains are essentially your money makers. They're your special sauce. They're why people buy your product. They're what differentiate you from the other similar products out there. They're really like the essence of who you are as a business. Supporting subdomains are typically things that aren't really core to your business, but are necessary for your business. These are the things that you wouldn't be able to do any of your core processes without them. So it might be something, actually I'll give examples later, but these are sort of needed for the core things, but aren't actually core in and of themselves. And then the final thing is generic subdomains. So this is really like the things that you really want to have around your house, the things you really want to have in your infrastructure, you need in your infrastructure, but they're really not unique to you. You could just go out to a store and buy the thing, because like problem like authorization, like I need to authorize things, but so does every other company out there. So there's probably some generic ways to handle this sort of thing. To think about this in another way, so your core subdomains, as you identify these, you want to make sure that these are the things you're really investing in. These are the things you're putting the most engineers on. You want to make sure you're building them in-house. You know for sure that they make money, and you really want to make sure that they're like, they've been given a gold star, right? Like you want to make sure they're robust and they're well thought out, and they're not going to break tomorrow. Meanwhile, supporting subdomains, you still want to invest in these. You typically still need to build them in-house because they're often somewhat tied to the core subdomains. And so if they're not supporting, like directly supporting, the other thing that sometimes gets classified in this area is things that might become money makers but haven't been proved out yet. So if your company is expanding into a new business area, that new business area might be a supporting subdomain because they have this theory that this new product is going to make a ton of money and going to be great, but nobody actually knows that for sure yet. So this would be also categorized as a supporting subdomain. And then generic subdomains, you probably still need to put a few engineers on it, but ideally, if you can, you want to buy these things or use an open source solution. Or generally, like if you do end up building a house, you probably could open source your solution. So these are sort of those category of things. And while you want to invest in them, you generally don't want to spend all of your money in them. It's worth noting, like I mentioned before, this is constantly evolving. So just because something is a core subdomain today doesn't mean it doesn't become a supporting subdomain tomorrow. Or just because something's generic today doesn't mean it doesn't end up being a supporting subdomain tomorrow. So it's worth rethinking about if the categories still make sense, if their engineering allocation still makes sense, things along those lines. So that's sort of domains and subdomains. The next thing is bounded contexts. So ideally, you would have your domains sort of wrapping, methods and classes and services in these clean, nice little like round circles, each section solving a particular problem. In real life, typically they don't quite match, right? You end up with some piece of functionality that's totally unrelated, but happens to live with this other code because it's written in a similar way. Or you end up with, things solving the same problem that ended up in totally different places. So realistically, while you want to try to get those to match as much as possible, realistically, there's this general mismatch. So boundary context sort of solves that. The boundary context instead looks at what's actually there. So it refers to what's actually the technical solution set that makes sense as a cohesive chunk. So to sort of look at those side by side, the problem space is defined by the domain, which consists of one or more subdomains. Meanwhile, the solution space is defined by the domain model, which consists of one or more bounded contexts. So bounded contexts really refer to what's actually built, what's actually there. Ideally, within your bounded context, you have clear and controlled entry points or APIs. And assuming you've done this right, and assuming this is true, then you can essentially treat them like black boxes, which is then sort of great because you can, pick different technologies for each of your black boxes. I'm not actually advocating for this, but, if it makes sense for one of your bounded contexts to have, one set of technologies, while a different one, it really makes sense to do something different. This enables you to do that because there's nothing actually saying, other than larger infrastructure knowledge and stuff, there's nothing actually saying that you can't do completely different things in these different areas. And then while you're doing that, you can then assign teams to these different areas. So each team really only needs to know that one set of technologies. Each team only really needs to know about the stuff in that one area, with the possible exception of needing to know some of these API routes between them and the other services or the other contexts they interact with, right? So you sort of just need to know those APIs and you need to know your thing, and that's it. So just as a quick caveat, I've sort of laid out precise definitions for domains, subdomains, domain models, and bounded contexts. In reality, unless you're like deep in the domain-driven design groups and talking to people who know a lot about this stuff, people are much more imprecise about the definitions, and typically you'll hear domain and subdomain sort of used to refer to both, and it's all a lot more fuzzy. So I don't know. Yeah, it's good to know the exact definitions, but it's also worth knowing that people don't always stick to them. And then, okay, so that's sort of probably the key things that are considered behind domain-driven design. But the final thing is ubiquitous language. And this really sort of ties more into that cross-functional team principle. So the idea here is that as you have different people working on a problem space, you really want to have a common language for everything they're doing. So this means that everything they communicate would use that common language, those common definitions. So if I'm somebody in marketing or if I'm a developer, I would use the same term in the test code and in whiteboarding discussions and in specs and in the actual application code and probably public documentation, right? So this idea is that everybody has the same shared set of words. It's worth noting that these are actually specific to their bounded context or subdomain. So to give an example from Box, we had a concept of a file. So what is a file? Now, if you happen to be on the content subdomain, which I actually was a member of for a while, we were responsible for the general file system. So we would have said that a file was the container object that sort of groups together different versions of the content over time, and it enables general file system capabilities, things like moving, copying, deleting. It's sort of this like container object. Meanwhile, we also had a storage subdomain. And if you ask somebody on that team, they probably would have said that a file is a blob of customer-owned data, just like bits and bytes that's identified by a unique name. It's just something sitting on disk somewhere. And this is actually okay, because the big key uh, behind ubiquitous language is that the people you're dealing with directly and the problems that you're solving, you have a common shared language. It doesn't have to be the same across everyone at the company. And in fact, that would probably be pretty hard to manage once you got over a certain size, right? So it's the idea. To give an example, somebody posted this. So you might have like a general user story that's sort of like, when a customer doesn't get her stuff, then, she can click on the I didn't get my things button, and then, flagged for free order. And if she hasn't, she has to talk to someone in customer success. And if she didn't have one already, then she can get a new item, whatever, right? That's that example is good, but there's a lot of things that are tied to implementation, like I have not received my items button. What happens if that button name changes? Or on the other side too, though, there's a lot of sort of imprecise language. So one person writing this, and like say the product person writes this, and then suddenly the developer is reading this, they might have a different interpretation of what's happening here. Meanwhile, if you have a common language, then you can say something like submitting an undelivered order notification, and then claim a replacement order. And ideally, these things would have a common definition within this group. And this means that as this is stated like this, it means exactly the same thing to the product person as it will to the developer. So then everybody can have a shared understanding. So that's sort of what domain-driven design generally is. I'm going to give some examples now to sort of solidify this a little bit, because I can dig into things a little better with examples. So I'm actually going to use Split as our general high-level domain example. So one example is we have high-level domain of feature flagging. So essentially what we do is we do feature flagging experimentation, allowing you to turn on and off capabilities for particular customers, right? So as you can imagine, feature flagging would be one of our key core subdomains. We call them splits. So within the split subdomain, you probably have things like storing the actual split information, being able to turn it on, being able to create it, being able to kill it if there's a problem with it. So basically being able to create and manage these actual feature flags as a core subdomain. Another high-level domain that we probably have, we actually have this as box as well, is the enterprise domain. So enterprise would be things like, you might have a core subdomain of enterprise governance. And what this might be is things like requiring somebody who's changing a split. So if I'm turning on a split in production for 10% of traffic, I might need to have somebody else approve that. So being able to set up approval flows, like that sort of thing. It might be things like limiting permissions, only allowing certain users to access certain things. Or it might be having a log of activities. So an admin can go in and see everybody who's changed a split, or things along those lines, right? So this is probably also part of a key of how you can sell to larger companies that care about a lot of these things. So it probably still fall into a core subdomain, but this is clearly a completely separate area. Meanwhile, in enterprise, you also have some supporting subdomains. So one example is enterprise administration. So things like being able to create users, being able to put those users into groups, being able to assign those groups to some of those things that I mentioned before, some of those permissions, sort of the user management side of things, right? So that's pretty essential. Like, we can't have this application without users and administrators and some of these things, but nobody's buying Split so that they can create users. Like, that doesn't even make sense. So this would be a supporting subdomain. Meanwhile, similarly, enterprise setups. So being able to create the account, delete the account. Again, nobody buys an application to be able to create an account. Doesn't make sense. And it's probably worth noting that both of these could potentially be generic subdomains. I don't know that they generally are, but it's maybe worth thinking about. And then I was just going to list a few generic subdomains. Often a lot of the sort of more infrastructure things tend to be, so things like authorization, security, notifications, messaging and eventing, analytics and reporting, and just general internal infrastructure. A lot of these things tend to fall into generic subdomains. Now there's reasons why they might not be, and like especially if you're like a security firm, maybe they definitely, like some of these definitely wouldn't be generic. And I'm not saying that they always are, but these tend to be common things. And it's worth noting, so everything I've talked about so far is sort of related to the main customer facing subdomain applications. It's also possible that you have some more internal facing subdomains. So for example, you might have tools for customer success, things like allowing them to log into a user's account. There's generally often a set of use cases around customer success helping customers. Same thing with sales, being able to sell and create accounts and create trials and all those sorts of things. And even legal, potentially. At Box, we had some things around legal being able to freeze accounts or things along those lines. So it's possible that you also have internal facing subdomains in addition to your customer facing ones. Okay, so that's domain driven design. Switching gears entirely, let's talk a little bit about layered architecture. So layered architecture, it's worth noting before I go into this definition that this, unlike domain driven design, there's not a clear set of words to describe this architecture. There are a number of blog posts. This is pretty common conceptual ideas, sorry. There's a number of different posts talking about the same concept, but they often use different wording and different phrases. This is what we chose to use at Box, so it's what I'm using here, but you might hear the same concepts with different names. So just to keep that in mind. So layered architecture is a way of dividing up the architecture between front end, middle tier, and back end in order to optimize for decoupling and reuse. So typically you're going to have an application layer, a business capability layer, foundational layer, and then infrastructure services. And again, these might have different names, but generally there's sort of these main concepts. And just sort of for some context, these would all live underneath a client tier. So the clients, so I guess everything here is on the server side. So there's clients, and then there's all the server side stuff. So I'm just going to be talking about the server side stuff for the most part. So the first thing is the application layer. And sometimes this is called backend for front end is a common term for this. There's a few others as well. The general idea here is that you have a service for each of your clients, an application service. And the general thought that is that, you know, if I'm in France or if I'm, you know, someplace on a mobile phone with like 3G connection, my call to my data center on the West Coast is going to be super slow. But once I'm in that data center, assuming we've done things correctly, all of those calls within the data center should be pretty fast. So the idea is that as the client, I make a single call to this application service, which then goes and fetches all the data it needs from all of the other services, sort of packages that and returns it to the client. So at Split, our main Split application would have an application service. It's often the case that public APIs also have an application service. Some people argue for this, some people argue against this. I'm personally for it, but it's worth knowing that it's pretty common for them to have their own application service. Meanwhile, like integrations, like if you have a Slack integration or something else, those might also have their own application service depending on how they're done. And really, I like to think of this as this allows each service to package the same thing in the way that they want. So you might have a lion underneath, but you can like show different pictures of that or different aspects of that. I'm not going to want the same experience on my smartwatch as I am going to want on my phone as I'm going to want on my browser, right? So this allows each of those services to get exactly the data it needs to display exactly what it wants to display. Within the application layer, things move fast. I'm sure you all know this. People like to change the UI. People like to play with layout, with coloring, with like everything under the sun, right? Ideally, you want to make this able to move fast, able to try things out, able to see what works, what doesn't work. Typically, the application layer, most commonly, is built with Node.js and is owned by a front-end team. But the idea here being that it allows them to move even faster. As they're building this new UI, they know exactly what they need. They can build that communication tunnel to the server, and then they can also then own the server code that then collects the data that they need. So you don't have a backend team trying to figure out what they need to send to the front end team in order to get exactly what they want. And this is part of why it's often written in Node, is because it's owned by the front end team. If you've heard of things like Falcor or GraphQL, these are also often in this layer. But it's also pretty common just to have REST APIs as well. So these are different ways of exposing the data that the client would then be getting. So that's the application layer. The next layer is the business capability layer. So I like to think of this as sort of where you're tying a bunch of your functionality together into a single thing. This is all of the complex business logic, what really sort of makes your application interesting, essentially. It's worth noting that within the business capability layer, a business capability service can call another business capability service, or it can call one of the foundational capability services. They're really sort of taking other things and building something else. They can also expand different bounded contexts or domains. So I might have something that, I might have a piece of functionality that requires different pieces of information. Like if I'm uploading a file, I need to both create that piece of file content we were talking about before and also store the actual bits and bytes that we were talking about before. So it's possible for this capability to span different domains. And really, sort of the main purpose of a lot of what lives here is so that you can have a consistent experience no matter where you go. So while you might want different displays and different ways of interacting with the application, if I'm buying a pair of running shoes, I want to be able to buy a pair of running shoes, whether I'm at the website or the physical store or at a race expo. At the end of the day, I want to give you money and get running shoes, right? So like that basic end-to-end flow needs to be the same and needs to work no matter where I'm going. Another thing that's pretty common for the business capability layer and like a place where this can be really useful is, assuming I'm logged in, if I go in on my iPhone and I start the process of buying some running shoes, then I get distracted and I put them in my cart, but I go off and do something else. Then I come back in on my browser. Ideally, I still have those in my cart and I can just check out and get them. And it doesn't matter that I started it on one client and finished it on a different client. That sort of state is saved and that state is able to be finished. So that's another use of this lower layer. Typically, this layer, it's not going to be moving as fast as the application layer, but you still want a decent amount of agility. You want to be able to combine things into new pieces of functionality and in new and different ways. So the final layer is the foundational capability layer. So this is really your building blocks that everything else is built on. This should be your, like the source of, like the single source of truth. These are your records. This is where actual data is stored and the actual information is saved. The foundational capability layer also often contains anti-corruption layers. So an anti-corruption layer is if you have you rely on an external service and you do things, or you have to call out to that service to do particular things, like say you're calling something in order to send emails, right? So ideally, you would want to wrap that service in a thin layer. And the idea here is that if that service changes, then I only have to change this thin layer, and instead of changing every single service that might call to that external service when they make updates. Allows me to update their thing more on my own terms. And then the other piece of it is that it basically, if problems happen, like say that service like goes out of business, I can easily replace it with something else without having to change all of my code. I can just change the layer, right? So these are also considered foundational capabilities typically. These are sort of the smallest building blocks within your larger domains and subdomains, and they will contain code. They should never really just be the database, but they also contain the actual data that's stored. So these are sort of the most basic building blocks that you have, which isn't to say that each of these necessarily needs to map directly to like a table or something like that. It might be the case that you have 3 tables that don't really make sense independently. So you would only ever access them together, in which case they would all sort of be together. And part of the beauty of having this layer is that then I can change the actual data structure underneath, and nobody else needs to know about that. Only I need to know about that. So if you have 2 different foundational capabilities, you really don't want them calling each other. So while things higher up the chain can call different things, at the lowest level, you don't want one thing failing just because something over here failed. And so in order to keep things decoupled as possible, you typically don't want them calling each other. Likewise, you don't want them accessing the same, you really don't want anything accessing the same information. So you don't want anything bypassing these and going directly to the database, right? Because you don't want like 3 things trying to access the same data, because they might not have the same controls in place, they might not be handling the data correctly, and so on and so forth. Likewise, you don't really want to be storing the same data in multiple places. So if I have like a profile picture stored in one foundational capability, I don't want it also stored in another, even if I'm trying to store the same thing in both every time. Because then as soon as one of them forgets the other one exists, you have problems, and you don't have a single source of truth anymore. So you really don't want this. That said though, you might have user concepts within 2 different ones. So for example, I might have profile information in one, and I might have billing information in a different one. And this would be for cases where these belong in different bounded contexts, right? So like with the profile, that might be more like account setup, social, like user sort of pieces of functionality, while billing is more around account management, potentially sales, other things like that, right? So these might be stored in totally separate areas, even though they refer to the same conceptual larger object. And foundational capabilities should be moving the slowest. You probably want these to be the most robust. You want to think the most about making sure that they're built well and built cleanly, because if you make a mistake, it bubbles up and affects everything else above it. But that said, you probably likewise don't want to be changing them very often. So they mostly should just be sitting there. And then you have the infrastructure services. So these are sort of everything else. They're sort of the weird stuff that doesn't fit in. They're often generic subdomains, not always, but often. And again, similar to the generic subdomains, they often include things like authentication, authorization, data access, messaging, API gateway, analytics and monitoring. These are sort of the special unicorns. I'm not really going to go into too much depth because that could be like an entire talk all on its own. So it's just worth noting that there are a bunch of other things that don't necessarily fit cleanly into this architecture. Okay, so for a couple of quick examples. So again, split examples. If I'm going to my main page at Split, I get sorry, by main I mean landing page. So if I just logged into my account, I'm gonna get things like a list of paginated list of splits that I own, right? I'm also gonna get some basic environment information. So if I happen to be on the production page, there's gonna be some information about the production environment. And then, but then there's also going to be some aggregated data. So things like statistics around my splits, right? And under the hood, this is probably going to have to actually get the splits, but it's going to do some additional calculations to massage that data on top. And so then that's sort of why that's on different levels there. And then all of this data is going to be packaged back together for this application in order to return that to the client. And then meanwhile, so that was the application layering. You also have the domain layer, or the domain division here, right? So you have this general split subdomain, and then you also have your environment subdomain. So the information about the environment would likely be separate. Then on a different example, so we have a feature related to that approval flow I mentioned earlier, where I can restrict who actually approves things for a certain environment. So if I want to say only people in the exec suite can approve changes on the production environment, for example, I could turn on this setting. So when I actually turn on this setting, there's going to be, it'll probably call like one thing in the business capability layer that's just like turn on the setting, but that thing is going to need to actually store the information that setting's on and who can actually approve. Meanwhile, it's also going to need to go ahead and reject all pending approvals that don't map to this new setting. So if I have an approval out with the potential approvers being people not in this list of approved approvers, then I'm going to need to go ahead and reject those. And then when I reject those, I'm probably going to need to get a list of all of those pending approvals and then reject each one. Meanwhile, I also want to send a notification that this is happening, which then you probably want that separate because I could send emails, I could send SMSs, you know, a bunch of different things, right? So you send a notification, it would be a business, and then the specific things are probably foundational. And then in terms of domains, again, you have the environment, so storing the settings on the environment. And then you also have changing like the actual change request, so rejecting those change requests. And then you have the actual notification area. Okay, so just a quick to back out a level to think about this in terms of actual services. You probably have your clients, they call into application services that are built on most likely Node.js and GraphQL, but you know, various other things are possible. They will talk to your backend services. It's pretty common to use OpenAPI here, but again, it could be GraphQL or something else as sort of your library contract layer between the application and the business capability services. And then you're going to have your business capability, your foundational capability services built in any number of typical backend languages. The other thing that's worth noting here that I've sort of drawn out is that it's possible to have your business and foundational services as separate services, but it's also possible that you might want to just combine them into a single service. And like the main reason probably being then you don't have to deploy as many things and simple things along infrastructure upkeep along those lines, right? The thing that's worth keeping in mind though is even if you keep them in the same service, a lot of what I was talking about in terms of who calls who and keeping things separate and having the ability to call foundational services directly is important, even if they live in the same service. Because part of the power of having these separate foundational capabilities is that it allows me to recombine them in ways I wasn't expecting later. It allows me to build new things because they're my building blocks, right? So it allows me to rethink about how I'm doing things as I move forward. So just to back up even further, so this is sort of what I talked about within the larger picture. And yeah, that's basically all I have.
All right, very good. I just wanted to bring up, I guess, if you have questions for Joy, you can ask them at this point. All you have to do is just unmute yourself. I just did notice we had a comment from Chris Cornacchia. Says that he asked about context and subdomains a few years ago, 6 years ago. So I guess it's more of a comment though than a question.
Well, basically what I was saying is that, you know, I've been studying DDD for a very long time, and I always come across this, that what's the difference between a subdomain and a bounded context? Like, where do you draw the line? And you know, so I asked that on Stack Overflow, and to this day, I still get people commenting and questioning it and putting their 2 cents in. But I really did like your the slide that you put up where it said the subdomain is the problem domain, the bounded context is the solution. And I was actually going to ask if you could actually put that back up so I could take a picture of it.
Yeah, sure.
Thank you.
I assume you mean my semi-definition slide one.
Yep, that one right there. Perfect.
Do you need me to make it bigger?
Nope, got it. Thank you so much.
Yep.
Right.
Yeah, we actually sort of clarified this because we noticed our group was having a hard time keeping these things straight, and so we found this was helpful.
Hey Joy.
Yeah.
This is Om. So thanks for your presentation. Just want to understand a quick question. So this is all like a concept, going domain-driven design, identify your domains and identify the entities. But when you actually work on that, you see a lot of area where domains are getting mixed, or they are not having the clear boundaries. They are having boundaries intermingled. So specifically want to know, like when you have an entity which is having another form like a customer and a user. So if it is spanning in 2 different domains, so is it going by, you know, a non-primary key? I'm talking typically in terms of database. Going with the non-primary key would make sense, or it is what people usually do, like keeping a GUID for customer and keeping GUID for user, so that at one point when they have same entity, they can be linked.
Yeah. When I was saying that you don't want things crossing, that's not to say you wouldn't have foreign keys. So I could have foreign keys still within a table, and in order to be able to link that information to a different one. I mean, that's super common. The main thing there though is I would want that link, then I wouldn't want to actually fill in that data within my service. It's more a matter of like, I'm saying, because that doesn't belong to my service, that belongs to that other one. So I would be saying, I'm connected to this thing, and you should go over there to get the actual information, because they're the single source of truth. They know what's going on. Does that make sense?
Yeah, in short, okay. So if we have like 2 different services, and is it always a true statement that their database or persistence would remain separate?
Ideally, with the idea being that then they can choose whatever data store makes sense for them, and they can switch it out independently. That said, there's a lot of, it's also pretty common for companies to have like a database and caching layer around like their main data store. And that also has its uses, right? Like it allows like all this common work that's put in to enable good caching that all these services can independently take advantage of. So that's also decently common, where there might be one database with this layer that a bunch of different services use. That said, ideally you would want to have it so that one service is only accessing the data they own. So even though they're going through this common layer, they're only accessing their own data. They're not crossing over and accessing somebody else's data directly.
Thank you.
Yep.
All right. Anybody else with questions? I see some in the chat. But I'm not sure if they were already. I think we had one from Lei Yang. It says, does foundation layer have to be in backend or the front end? Or can the front end have some sorts of foundation layer?
I honestly haven't thought about that. I mean, I think the main thing behind the foundation layer is that you want to, it's your basic building blocks is the things you're reusing. So if you have things like that in the front end, there's no reason why you couldn't.
Okay. And then one more, it says from Jeff, thank you for the informative presentation. Oh, that's for me. I'd like to share this to the team. I can get this up tonight. I'm recording the presentation right now. All right.
I have a front end question if we have time for that.
Yeah.
I'm actually in a current debate with one of my developers. We have an enterprise application, and we generally made extensive uses of the Kendo UI grid. We have like a lot of tabular data. This person has just come onto the team and saying that nobody uses grids anymore, that it's that front end has to use different structures. Does anybody have any experience with that, or do you guys use grid with tabular data? Does anybody have an opinion on that?
Somebody just wrote, I use grids, rummy. And then, I mean, you can pretty much use, I mean, if you know, like the thing with like these kind of libraries, I mean, if they're useful to you, use them. I mean, don't feel like you don't need to use them because something newer came out. Sometimes like newer stuff is not yet like, you know, I guess foolproof. So if you like older service, go for it. Older library, go for it.
I have a separate question to ask is if they're not going to use a grid, what would they use?
In some instances, he was showing where there was a table being used, and so then the filtering wasn't actually on the table, but so if you clicked on something, the data would then occupy, or it would bind to certain text fields in an above layer. So you wouldn't do actual grading. What's that?
Is this a debate between using a grid or using a table?
I guess so.
So grids and tables are totally different. For me, in my experience, I use grids as kind of like containers to hold controls. I use tables to look at data.
Okay.
So if I have if I want to use a button and then I want a text box with a button in a certain position, I would use a grid. But if I'm going to use like some type of presentation where I need to express some data, I would use a table because table you can filter.
Okay, thank you.
So it depends on what you want to use. So both are great, but they should be used differently.
Gotcha. Okay, thank you.
All right, a few more questions. Oh, I guess Joy just replied on the chat. Does anybody else have a question at this point? All right.
One thing before we leave.
Mm-hmm.
So microservices, we are, you know, we just not discuss one point. When we talk about microservices, it always come one common thing called Docker. So is it always have to go always with Docker? I mean, not necessarily, but does it make sense always to go with Docker? Containerizing with Docker?
You don't have to containerize stuff. In fact, at Split, we currently aren't using containers, but that said, we are trying to move towards containers. I mean, containers just make it much easier to deploy the same thing anywhere. So
yeah, one of my friends suggested, okay, if you are not using Docker, then it's a monolithic kind of you know, what it makes a difference if you put everything under one classical service.
I wouldn't say that. It's just more that deployment is more challenging. So you're just, the more services you have, the more overhead nightmare you're going to have. But I mean, that's a little true with Docker as well, but it's way more true without it.
Yeah. And does every microservice need to have a common authentication mechanism?
Authentication?
Mm-hmm.
Not necessarily. You don't have to. I guess I don't know of a good use case why you wouldn't. What's what's pretty standard is that you would have a main external to internal authentication. So the external one could then use like a bunch of different authentication types, and it would change that into an internal token, which then each of the services would have a library essentially that could then decode that token. So the idea then is, yeah, you have like one that translates external to internal, then like simple internal one.
But having them under one API gateway would be certainly recommended.
Yes.
Okay, thank you.
I mean, you don't have to, but otherwise each service is going to have to re-implement essentially the same thing. Which is
I mean, recommended. That means, yeah, usually one company does split the microservices and then go for one web API. I mean, one API gateway.
Yeah.
Okay. Yeah. Thank you.
All right. I think, yeah, if nobody else has any questions, then we can call it a night. The video will be available on youtube.com/JavaScriptLA. So be sure to subscribe. And then all information can be found on javascriptla.net. That's where you'll find more information about the next meetup. And otherwise, I just wanted to say thank you all for coming, and thank you, Joy, for the presentation.
Thank you for having me.
Round of applause, please.
Thanks, Jay.
All right, see you all at the next meetup. Thank you so much for coming. Bye.